So let's do another example. This is iron 2 plus permanganate, giving us iron 3 and manganese ion. So this example doesn't have the little cheat sheet on the side. What's the first thing that we have to do? Not that we maybe should do, but that we have to do. Half reactions. So the iron 2 and the iron 3 obviously are part of the same half reaction, right? So we'll make that one half reaction. Fe2 plus and Fe3 plus. And then the permanganate ion and the manganese ion must be the other one. So we made two half reactions. What do we do next? Balance with respect to, not charges first, mass first. Yeah, so we want to get all the atoms to balance first. So the first one's easy, right? It's already done. The second one, we have one manganese on each side, but there's 4 oxygens over here. So we can't just add coefficients. We have to introduce oxygen. And how do we do that? H2O. This is all happening in aqueous solution. So there is water. It's not like we're making something up. So there's 4 oxygens on the left side. That means I'm going to add 4 water molecules on the right side. Okay? So we fixed our oxygens, but now we introduced an issue with hydrogens. This is in acidic solution, and so we balance the hydrogens with H+. So I've got 4 times 2, 8 hydrogens over there. So that means I need to add 8 hydrogen ions on the other side. Everybody okay with that? So we balance with respect to mass. Now we balance with respect to charge. And this is where we add in electrons so that the charges are equal on each side of the arrow. So that first equation, I've got positive 2 on the left side, positive 3 on the right side. All I can do is add negative electrons. So if I add 1 electron over here, I've got a negative 1 and a plus 3, and that equals plus 2. In the lower one, we've got more charges hanging around. We've got positive 8 and this negative 1. So we've got a total of positive 7 on that side. And over here we have positive 2. So it might be helpful to write that out. There I've got plus 2. Here I've got plus 7. Adding negative electrons. So if I added 5 electrons to this side, I could bring that down. So now we've got negative 5 and positive 7. We get the same charge on each side. We should be adding electrons on the product side for one and on the reactant side for the other, because one's oxidation and one's reduction. Any questions? Yeah.
So the 8H plus and the 1 and the O4, that's what you do your 7 on the charge?
Yes. Yep, so I've got 8 positive 1 charges and a negative 1. Any other questions? The individual steps aren't really very difficult, but you have to put them all together successfully, and that can be a little challenging sometimes. So we want to be able to add these 2 equations together so that the electrons go away. Because our balanced redox reaction doesn't show any electrons, because the electrons are transferred directly from the one thing to the other. So we've got 5 electrons in the denominator and only 1 electron in the numerator. That means there must be 5 of these occurring. So I'm going to multiply it by 5. So I'm going to say, well, let's do 5 iron 2 ions, making 5 iron 3 ions and 5 electrons. The 5 electrons that are released by this half reaction are picked up by this half reaction. So then we add these 2 together, and the electrons will cancel out. The electrons should always cancel out because we're making it that way. Then we're going to write down what's left. The actual order that you write these in doesn't matter. I typically tend to kind of follow what the original unbalanced one was. So I'll start with the 5Fe2 plus we've got 1 permanganate ion and 8 hydrogen ions, bless you. And over here we have 5 iron 3 ions and a manganese 2 ion and 4 water molecules. And there's our balanced redox equation. Any questions? If you look at this equation and you just try to balance by inspection, you're going to get frustrated because there's 4 oxygens on the left and there's no oxygens on the right. And so what do? You take it into half reactions. Any questions? Let's do another one. Copper metal plus nitrate, giving us copper 2 ion and nitrogen dioxide. So what's the first step? Half reactions. So we'll put the copper in 1/2 reaction and the nitrogen oxygen things in the other. This one's getting oxidized. That means this one, something's getting reduced. It's not as obvious, but here we're going increasing oxidation state. So we made half reactions, then we balanced by mass. So the first one's good. The second one, we've got 1 nitrogen on each side. We've got 3 oxygens over here and 2 oxygens over there. We need to add an oxygen. So what do we add? Water. Now our oxygens are balanced, but now hydrogen isn't. Yeah. So we'll balance hydrogen by adding hydrogen ions on the left side. And it seems like we're pulling those out of thin air, but we're not. We're pulling them out of the aqueous solution that these things are floating around in. Then we balance for charge using electrons. So I need 2 electrons up here. And what do I need on the bottom? 1 electron on the left, because I have +2 and there's this minus. Over here I've got 0. So if I have 1 electron over here, then I'll end up with 0 on that side as well. Everybody okay with that? So we need to add these together so that the electrons will cancel out. So we need to do some multiplying. We've got 2 electrons up here and only 1 down here. So if I multiply all the coefficients in that second equation by 2, then the electrons will work out. So that's a 2, this becomes 4, that's 2, and 2, and 2. I'm going to add these together. We've set it up so that the 2 electrons produced by the oxidation are gained by the reduction, and so they cancel out. There's nothing else that cancels out in this one, but in some of the later ones we'll find out that there's waters and hydrogens and all kinds of other things on both sides. We're starting out with the more simple ones. So copper solid plus 2 nitrate ions plus 4 hydrogen ions is going to give us copper 2 plus 2 NO2 plus 2 water molecules.
So the H plus is our only electron. There's no electron on the other side, that's why we added only one, right?
Say that again?
The H plus is like our only electron, our only plus, and since there wasn't one on the other side, that's why we only needed one electron.
Yeah. So before we multiplied by 2, we had 2 hydrogen ions, so that's a positive 2 charge. And we had 1 nitrate ion, that's a negative 1, and so that adds up to plus 1. On the other side, there's no charges at all, it's 0. So that means we have to make the left side equal to 0. So we're just trying to get the sides equal. In this example, both of them ended up with 0 on both sides. But that's not necessarily how it's going to work out. They might both have charges on both sides. They just need to be equal. So there's our balanced equation. So this nitrate, it's important to remember that this is a net ionic equation. That nitrate probably came in with some sort of a cation, probably something like sodium or potassium, because those things don't precipitate. And this copper ion here is going to have some sort of an anion associated with it, and that might be the anion from the acid. It could be lots of different things. Okay, so that was in acidic solution. What if we have this occurring in a basic solution? So we're going to do the same steps, and we're going to add one thing. So when we're balancing with respect to mass, we're going to do what we did before. We're going to balance oxygen by adding water. We're going to balance hydrogen by adding H+. And then we say to ourselves, well, this isn't an acidic solution, so I need to neutralize those hydrogen ions. And I'm going to do that by adding the same number of hydroxide ions to each side. So that's not going to mess up the balance at all, but that's going to get rid of the hydrogen ions, because in a basic solution you have an excess of hydroxide ions. We can't just balance the hydrogen by adding hydroxide ions, because that screws around with the oxygens and it makes things really complicated. So we're just going to add hydroxide ions to neutralize the hydrogen ions. So let's do some examples. So this one, iodide and permanganate in basic solution. So we're following that same pattern. We're going to make 2 half reactions. So let's make the I minus. Must be going to I2. And then the permanganate going to the MnO2. So we'll balance with respect to mass. This first one we have I2, and here there's only one I minus, so I need to put a 2 in front of that so that the I's balance. Down here I have 1 manganese on each side. I have 4 oxygens on the left and 2 oxygens on the right. So I need to add 2 more oxygens to the right side, and I do that by adding water molecules. So now my oxygen is balanced. But now I've added hydrogen into this equation. So I have 4 hydrogen atoms in those molecules, so I need to add 4 hydrogen ions over here to balance the hydrogens. So this is the same as what we were doing before. Here's the difference. This is in basic solution, so we can't have hydrogen ions sitting around. So what we're going to do is we're going to add 4 hydroxide ions to neutralize the 4 hydrogen ions. We had balanced this with respect to mass, and we don't want to mess that up. So we're going to do the same thing to both sides. Everybody okay with that? I balanced it with respect to mass, and then I just added the same number of hydroxides as I had hydrogen ions. So at this point, what I like to do is simplify this a little bit, because what does hydroxide ion plus hydrogen ion make? Water. So I could take these and rewrite them as 4 water molecules. So I'm going to do that. So I'm going to erase those. And write that as 4H2O. Is there any more simplifying we could do of this? We could cancel out 2 of the water molecules, right? Because we have 4 water molecules over here and we've got 2 over there. We don't have to do this now. We can do it at the end. I think it's a little easier to do it now. So 4 water molecules and 2 water molecules, I can get rid of 2 water molecules on both sides. Now let's double check that things are still balanced. So I have 4 hydrogens over here, and I have 4 hydrogens over there. I have 2 oxygens plus 4, that's 6 oxygens. And I have 2 oxygens plus 4, that's 6 oxygens, and 1 manganese on each side. Balanced with respect to mass, and that's what we were trying to do here. Okay? Now we fix the charges. I've got 2 minus on this side, so I'll add 2 electrons to the other side. Same charge on both sides. When I look at this bottom equation, I have a -1 charge here, that's neutral. Over here, that's neutral, and I have 4 negative. So there's a total of -4 on the right side and -1 on the left side. So I need to add how many electrons? 3. And so then we've got 2 electrons and 3 electrons, and the lowest common multiple of that is 6. So we need to multiply each half reaction in order to get 6 electrons. So we multiply the top one by 3 and the bottom one by 2. So I multiply the top one by 3, so that's 6 and 3 and 6. Multiply the bottom one by 2, so 3 times 2 is 6, 2 times 2 is 4, and yeah, times 2. Yeah, it's so easy to forget. What am I multiplying by? I'm multiplying by 2 times 2 times 2. And go back and check, because I tend to just switch in the middle of the equation. So if I screw up, please yell at me. Kindly, but loudly. Okay, so as we planned, the electrons are going to cancel out. And then you can also look around and see, is there anything else? Sometimes there's hydroxides or water molecules or something that will cancel out. We already fixed all of that in the second equation. So nothing else is going to cancel out. I'm just going to copy things down. So I have 6 iodide ions from the first half reaction. And in the second one, I have 2 permanganate ions and 4 water molecules. And then my products are going to be 3 iodine molecules, aqueous, 2 MnO2, and 8 hydroxides. And then you should always check the charges balance and the atoms balance. Any questions?
How would you know that it's a basic?
That's an excellent question. How would you know that it's a basic solution? Because the question will tell you. Yeah. So this prompt says balance the redox reaction in basic solution. The previous one said balance the redox reaction in acidic solution. If it doesn't specify and there aren't any hydrogen ions or hydroxide ions in the equation, you could do either. I'd do acid because it's easier. It's just one last step. Any other questions? I think we have another one, another example. Okay, so this one's a little more fun. Balance the redox reaction in basic solution. So, are we starting to remember what the steps are? What's the first step? Half reactions. Okay, so it's helpful if your arrows line up. So I'm going to put the ClO minus over here and the thing most like it over here. And then I've got the thing with chromium in it. And the other thing with chromium. I'm having trouble with my Q's this morning. Hopefully my P's are fine. What do we do next? Balance for mass. So, first equation, we got one chlorine on each side, and we have one oxygen on the left side. So we balance that by adding water. And you can save yourself some messiness by just leaving a space there, because it's a good chance you'll have to write some coefficients in there. So now my oxygens are balanced, but I introduced hydrogen. So I balanced the hydrogen using hydrogen ions. So I need 2 of those, 2 H+. And that's the easiest way to balance the hydrogens because it doesn't do anything to the oxygens. You're just adding a single element. It's a lot easier. But then we see that this is in basic solution, so we have to fix that. So we can add hydroxide ions to balance the hydrogen ions. Now, there are different ways, different orders that you can do some of these things in. You could balance this as if it were an acidic solution and then fix that at the end, or you can take care of that individual steps in the middle. What do you guys want to do for this one?
I like doing it in the middle.
You like doing it in the middle?
Especially speed up doing it again.
Let's continue doing that then. So 2 hydrogen ions, that means I need to add 2 hydroxide ions. Oh, there, okay. And I had it balanced by for mass, and so I need to do the same thing to both sides. Otherwise, I'm messing up what I just accomplished. So, in keeping with the idea of fixing things as we go along, we're going to look at these 2 hydroxides and 2 hydrogen ions and say, well, that would be much simpler just written as H2O. So I've got 2 water molecules over there. So you can see that pencil is a good writing choice. Dry erase markers and whiteboards also work really well for this. Or notability. So I got 2 water molecules. It's all still balanced for mass. And then I say, well, look, I've got a water molecule over there and 2 over here. I could get rid of 1 on each side. So I'm going to get rid of this one. I'm going to subtract that 1 from that side and 1 from this side. And then double check, is it still balanced? Yes, it is. that didn't work very well. I don't know what happened there. I was trying to be fancy. Didn't work out very well. I'll stop. Okay, bottom reaction, half reaction. 1 chromium on each side, 4 oxygens on each side. So far, so good. 4 hydrogens on the left and then on the right. Oh, wait. No, never mind. We're still doing mass. Just had a brain fart. So I need 4 hydrogen ions over here to balance these 4 hydrogens in that. Okay, yeah. It is 4. I wrote 2. Thank you. I said 4, and I thought 4, and I wrote 2. I'll blame it on my Apple Pencil. Bad Apple Pencil. Is that better? Yeah, you're welcome. Thanks for catching that, because that would have been messy later. Throw off the whole thing. But we can't have hydrogen ions hanging around, right? Because this is in basic solution. So I have 4 hydrogen ions. I'm going to add 4 hydroxide ions. And if I do it to one side, I have to do it to the other side. And then I say to myself, well, 4 hydrogen ions and 4 hydroxide ions, that's 4 water molecules. So I'm going to erase those. And write 4 H2O. Pardon me? That's a good question. Could I cancel the H2Os now? No. I need to balance for the charge first. Because when I balance for charge, I might be multiplying them by different numbers. And so it's not going to work out. But that's an excellent question. So now I have to take care of the charges. I've got a -1 charge on this side, and I've got a -1 and 2 -1s on that side. So 3 negative on the right, 1 negative on the left. So I need to add 2 electrons to this one. So -2 and -1, total of -3 over here and -3 over there. Second one, I've got -4 and another 1, so total of -5. And then over here, I've got -2. So how many electrons do I need? 3. So I've got -5 on both sides. We're not trying to get 0, we're just trying to get the same. Everybody okay? Now we need those electrons to cancel out, and so we're going to multiply the top reaction by 3 and the bottom by 2, so that I can get 6 electrons on each side and they'll go away. So sometimes it's helpful to actually make a note to yourself, okay, this one's times 3 and this one's times 2, so that when you get in the middle and you forget what you're doing, you can go back and look at it. I'm multiplying by 3, so this is going to be 6 and 3 and 3 and 3 and 6. Yes?
Didn't you say they have to be the same on both sides? Like, would not be 3 on the top one? Because there's 2 OH and 1 because you added 2 electrons.
I added 2 electrons. I added.
I realized.
You okay?
Yeah.
Yeah. It's really easy to get mixed up because there's negatives or positives all over the place. And so if you find yourself getting mixed up, if you're not seeing it real clearly in your mind, write it down so you can literally see it with your eyes. Yeah. And don't be afraid to ask me a question and then end up realizing, oh wait, it's fine. Because sometimes it's not. And then nobody asks, why is that a 2 when you said 4? And then we end up just in a big old mess. So always ask. I won't make fun of you. So this bottom one we're multiplying by 2. So this 4 becomes an 8, and there's a 2 here, and a 2 here, and this 4 becomes an 8, and this 3 becomes a 6. And now I have 6 electrons on each side, which is what I was trying to do. So now we're going to add these together. So the 6 electrons are going to cancel out. This is the place where we could cancel out some other things, because we've done all the multiplying that's going to happen. So I have 3 water molecules on the left side, and I have 8 on the right side. So if I subtracted 3 water molecules from each side, these 3 would go away, and instead of 8 here, I'd have 5. Right? 8 minus 3 is 5. What else could we simplify? The hydroxides. So I have 6 hydroxides over here, and I have 8 over there. So if I subtract 6 from both sides, the 6 goes away, and the 8 becomes 2, because 8 minus 6 is 2. So I think we're done, so we'll copy down what we've not crossed off. 3ClO minus plus 2 of those chromium hydroxide things. And then I've got 2 hydroxide ions. On the right, I've got 2 chromate ions and 3 chloride ions. And 5 water molecules. So we'll finish off that arrow before the computer so rudely interrupted me. And we'll do this again on the right side. Chromate, 2 chromate ions, and 3 chloride ions, and 5 water molecules. So I think I did everything correctly. This one was kind of complicated, right? There were a lot of things. There's so many places you could make a little mistake. So here, I would definitely want to go through and check. So let's check. 3 chlorines, 3 chlorines. Ooh, I don't want to do oxygen yet. 2 chromiums, 2 chromiums. I guess we have to do something messy. 2 times 8 is 2 times 4 is 8. 8 hydrogens and another 2, that's 10, right? And, you know, there's no shame in writing that down. 10 hydrogens. And then over on the right side, we see 5 times 2 is 10 hydrogens. Okay, so that's good. Oxygens, I've got 3 oxygens here, and I have 2 times, yeah, see, this is getting ugly, right? So I've got 3 oxygens, and I've got 8 oxygens, and I've got 2 oxygens. So that's a total of 13. And then over here I've got 8. 2 times 4 is 8. And 5. Oh, cool, that's 13. Phew. And charges, 3 negative and 2 negative and 2 negative, so I think that's 7. And this is 2 times 2 is 4, and 3 is 7. So all the atoms balance, and the charges are equal on both sides. Regardless of how you got there, if that's true, you're good. Any questions? There will be a problem like this on the next exam. Not the one on this chapter 19, that exam. Okay, so there will be, promise. And it will be an icky one. Won't be a really simple one.